Morning. Morning, API junkies. For some of you, it's the third day in a row, or the beginning of the third day of listening to and talking about APIs. So I think, give yourself a hand for that, right? Yeah. So today I'm going to talk about a potential customer that we all share. A customer that I call the architect, who isn't quite sure about this API thing. And I realize actually I'm making an assumption that most of us are API providers. In English, there's a saying about making an assumption, and that is that you miss out, when you make an assumption, you miss out on an opportunity for audience interaction, I think at least that's the rough translation. So that is to say, if you're an API provider, raise your hand. If you provide an API, there we go. Keep the hand up and raise that second hand if you have too many developers using your API. There's a one double raise. Those of you who raised you can put your hands down now. Yeah. Those of you who raised the one hand, this talk is definitely for you. So most of us in this room probably are on board with this story about the platformification of business, about building things on top of APIs. Here you have your typical developer, clearly a junior developer in this case, but any developer is going to be building on top of APIs, perhaps using Orchestrate as a database, we hope so. Building in the cloud for sure, social login, probably even some internal services, building on top of their own APIs the same way that they would build on top of an external API. And this is a wonderful world that we're building where you can take the seed of some functionality or data from one company and plant it, and everything will flourish and be this great utopia. And we're all on board with that. But today I'm talking about the architect who is not so on board. The architect who, when looking at this landscape, sees something more like this. And so our job collectively is to try to find that middle ground, to try to help the architect see that great world. And the only way to do that is to understand that this is what the architect sees. So who is this architect? Not necessarily an old man, not necessarily even a man. Classically, it would be the chief information officer or someone with a high-level title that is saying to the masses, this is what we will use. But that's not even always the case. These days, an architect could be a senior developer on a team, could be just one of the developers who has really strong opinions. And people get tired of saying, come on, okay, fine, yeah, we won't use an API for this. Right? So the architects are all around. And as we're all talking to these architects, we need to speak to the things that they see that are shortcomings of APIs. And so I think there are 4 areas where we can convince the architect, 4 areas where the architect is skeptical. And that is control. They want the ability to control anything that is part of their application. Reliability. They don't trust you more than they trust themselves and their own team. Security. Along the lines of reliability, they don't trust your security. And then finally, longevity. They don't think you're going to last as a company, as a product. Certainly not long enough to build their application and count on you. So those are the areas, and I think that no matter the type of API, some or all of these areas factor in, whether it's an infrastructure API, more content or data type of API, and then even if the API supports the product, or maybe if you're somewhere in the hazy gray zone in between those 3. I think there are pieces of this where you're going to have to convince the architect. There's a children's TV show called Bob the Builder, and it's a show about a guy named Bob, and Bob's a builder, a construction guy, and he often shouts out to his coworkers. He says, "Can we build it?" And then they answer, "Yes, we can." So, for example, it would be kind of like if I was Bob, I would say, "Can we build it?" And then, this audience is great. So, as easily as you just said, "Yes, we can," developers also tend to answer that way. When they look at a problem, they see a fun project. So, yes, they can build it, but they don't always need to. Yet that's sort of the instinct of a developer is, yes, we can build it. If they're not going to build it, they at least want to be able to touch it. They want to take an open source project and host it on their own servers. Be able to at least have that control, to know that it's there, that they could tweak it. So those are some of the directions that the architect comes from. Now let's take a step back and let's talk about, your company and your biggest competitors. And so the way you see it, you and your 3 competitors are all going after the mind share of this developer. You want this developer to integrate with your API over competition 1, 2, or 3. But in reality, our biggest competition is actually the developer themselves, the potential customer. Building it in-house, the yes we can answer is all of our biggest competitor. And so it's to our advantage to all try to be able to convince the architect to not do that, to build on top of APIs. And the secondary one is, yeah, you want you and probably not your competitor. So one way to go about that is to think about standards or conventions. Now these are all of the multiple standards of widths of railroad track. And I actually learned as I was doing some research that the Nordics are maybe not as standard as other places. So I'm not sure how well this argument plays out here. But so this is the most common, the 1,435 millimeter width. But it's safe to say that if I were building a train, I would at least choose one of these. And we can do that with the technology we provide as well. So an example from Orchestrate, we have a search API. And rather than creating our own way to query this search API, we chose a standard, or at least a convention, the Lucene query syntax, so that the developer who integrates with us at least has there's a control aspect of knowing that if they switch to something else, something else that used Lucene query syntax, all of their queries would still work. We can all do the same thing with our client libraries. So this is the Node client library for retrieving and saving data into the database, and you can see it's a fairly simple way of doing that. And that for the extremely skeptical architect, they could build a duplicate library using the same interface that stores or retrieves the data from another data source, making it easy to be able to switch. This has actually been done before in other aspects. I wrote a book on mapping APIs about 4 years ago, and I used an open source wrapper library called Mapstraction for all the examples, where You can write it once, and then with changing one line of code, you can switch between any of about a dozen mapping providers. So if you go with Google now, you can switch to MapQuest later very easily. And so there's a precedent for this sort of abstraction in APIs. So another way to give that control is to provide a way to get any data that you put in out. So if there's some way of storing data in your API, you want to provide a way to get that back. Not just API calls to get that back, but a way to export it all at once so that the developer can take that and move it to somewhere else. Or at least have the knowledge that they are able to do that, to have that control. Along the same lines, if you're a content or a data API, it may seem crazy to offer up everything as a bulk download, your entire data set. Especially since you've chosen an API approach. But there's actually a company that does just that. Factual has data on millions of business listings all over the world. And they provide this via an API. And those listings are updating often, but they also have an option for a data export. And there's a company called Facebook that takes advantage of that option. And anytime you check in or add a location in Facebook, it uses factual locations to do that. Now, Facebook is not going to be making an API call to factual every single time someone's doing that. So for them, having the data as an option makes it possible for them to use it. For some architects, just knowing that would be a possibility is comforting. And even though it is completely against the sort of idea of this utopian world that we talk about, again, having an option to be able to host a service yourself gives that feeling of control. Anyone remember the fail whale? Yeah, a few. And even more nods and a few tears, it looks like, yeah. So, the fail whale is gone from Twitter now. Twitter downtime is not necessarily gone. In March at South by Southwest, I was giving a workshop on Zapier and if this, then that, helping people use APIs without writing code. And it leaned pretty heavily on Twitter. I'm not going to say this is the reason Twitter went down for our 20 people in the workshop, but people started saying, hey, this isn't working. And we finally figured out, oh, Twitter is down. That's causing this problem, which was difficult for me giving a workshop. It was actually a little bit harder for the guy who was on the other side of the building. Biz Stone, the co-founder of Twitter, had a panel about Twitter, accepting questions via Twitter during this Twitter downtime. So API downtime, absolutely a factor for the architect, even for large companies like Twitter. This was an API survey from a couple of years ago. And normally when I show this slide, I talk about how developers actually care more about a documented API than whether the API is up. But that difference is very slim. And number 2 and number 3, service availability and service responsiveness, right up there on importance for developers. So it's certainly something that the architect is going to think about. So that Twitter downtime I talked about. A couple of days later, I checked Twitter's status page. They've got a good status page here. It breaks it down by calls. But interestingly, March 11th was the day of the downtime. There's just no data there. So this actually ends up, because of that, this ends up breaking all three rules, all three goals of a status page that I think should be there, which is to be transparent. Clearly they weren't in that case. To be helpful and to be proactive. So I wanted to show a few examples of good status pages and ones that achieve these factors. At a base level, just providing status updates. So this is Stripe's, this is their Twitter feed, but also shows up on their developer page. And it's a description of any issues that they've seen recently. Showing the current health. Facebook does this, Stripe as well in an even simpler fashion. And Twilio breaks it down by ways of calling its API and then shows its current right along with the recent, which is, of course, another best practice is being able to show the recent issues. Here's API response time and error rates in the Facebook API. Stripe going back 90 days and using color codes for minutes of downtime. And then I think the best example has to be GitHub's status page, which breaks it down by a lot of different areas here and then lets you look by just today, the past week, and the past month. So extremely transparent, helpful, certainly proactive. So those are some ways that we can convince the architect that your APIs are reliable, assuming that your status page has good information to share. So if it doesn't, that's the first thing you fix, is actually be reliable. So security I won't talk a lot about. There's an entire talk coming up next about security from someone who knows a lot more about it than I do. But certainly the base level is to secure your systems and to help your developers be secure by not sharing their passwords, for example, or not having the end users share their passwords. And this is kind of the base level. I want to talk about a couple of other areas that you might not always think about as security. One is a process for data access. Again, assuming that you're accepting data from developers or from end users through the developer, having a way that your employees only access it in certain situations. It doesn't have to be as complicated as this flowchart, unless it needs to be, but having a defined way and sticking to it is an important way of building trust with the architect. Similarly, privacy. If you're accepting end user data, being really clear about how you use it or how it can be used by the developer is an important aspect of building that trust. And helping developers to do the right thing. So your security, your practices may be perfect, but if you have developers that are putting their API keys in their GitHub repos, then that's going to reflect poorly upon you. And then finally, data ownership and being clear about that. If you need to have some ownership over the data that comes in, spell that out clearly, because no one will read your terms of service except for the person that puts it on terms of service didn't read, in which case it's going to be spelled out clearly. So you might as well be the one to communicate that message. And of course, if you don't have to own the data, then you probably shouldn't put that as a requirement in your terms of service. So now the biggie, the longevity. Face.com was an API that did facial detection, recognition, had some ways to be able to discover mood or whether they're smiling. This photo from Laptop Mag actually shows that it wasn't always particularly accurate, but I'll tell you, it was always fun. And I went to a lot of hackathons that were not sponsored by Face.com, yet had many developers using the Face.com API because it was so fun to play with. So I'm talking about it in the past tense. I think when we talk about company longevity, we know certainly some companies die, others get acquired, but in either case, they often go away. And that was the case for Face.com, which either made developers punch someone or cry like James Vanderbeek when Facebook bought it and pretty quickly shut it down. And I have personal feelings about this as well, because one of my favorite apps was built on Face.com and gave you a score for how surprised you could look. And I was pretty good at it. And that app is dead now because there's nothing that does that. So companies go away, companies get bought, and the architect is therefore skeptical that one of those things will happen to you. So I think the best way to be able to argue against that is to know where you sit in John Musser's API business model flowchart. To be really clear, and by the way, you can, I tweeted this out, and you can go to this bit.ly here because I know you can't see in detail what's on this slide. But to know where you sit there, to know how your API supports your business model of your company, and then, if necessary, if it isn't obvious, communicate that out to developers, to the architect. And this is the best way to combat either of those problems of company goes away, because if you have a business model that works, company doesn't go away. And if you have a business model that works and you're acquired, well, probably the acquiring company is going to keep that going because it's a business model that works. So knowing where you sit here, and that's the reverse of that is my advice to architects whenever I talk to them, is I say, think about where you think the company sits here, and does it make sense that you know, wherever they sit, that is going to be a successful strategy for them. But it's not only companies that go away and get bought where longevity is an issue. It used to be, if someone asked me what API you should choose if they had between one from Google and one from some startup, I would say, well, Google, because it's going to be around, right? But not necessarily the case from Google or other big companies these days. About 1 in 3 of all the APIs that Google has ever made public are now unavailable. We all are probably pretty familiar with the way Twitter has backpedaled on its API. And Netflix, once still a big API story, but on a public API front, has slowly pulled back from that until just 2 months ago, it finally said, okay, we're really done now. And I could go on and on about these, and I'm sure you all could go on and on with examples of companies that have pulled the rug out from under developers. But I think it's important to understand that when someone worries about API longevity, what they're really asking for is control. Let me repeat that for both emphasis and to quote myself from 10 seconds ago. Worrying about API longevity is just another way to ask for control. Which is to say, all of the ways that you can argue for control, you can argue for longevity. Give them an option to where if one of those things happens, that you get acquired and you go away, or you go away and you go away, that there's some way that they still have control, that the architect still has control. And I believe that the architect can be convinced, but it's not going to be just you talking about how you're better than your competitors, but rather us all making these arguments about these 4 areas. And remembering that to the architect, they're seeing this. And through the 4 areas that we've discussed today, we need to help them see how it can be like this. So thank you.